It is what it is. All right. Um. So what we're gonna talk about is at first we start with a sequence, and sequence is basically sequence can diverge. When situation sequencing can diverge? Okay, so sequence diverge when limits of n approach infinity of a to the n becomes infinity. What other case? Can you tell me sequence diverge? Second case that it can be diverge. When they fluctuate, so for example, is -1 to the n. So you got -1, +1, -1, +1, -1, +1. It's oscillation. So oscillation, right? So those are two things. We have talked about that we can, when we deal with sequence, so we can compare. There was two ways to say it's monotonic. What is a monotonic? Okay, so monotonic is gonna be strictly. How to spell strictly? T-R. So no. S-T-R-I-C-T-L-Y. Okay. Strictly increasing or strictly decreasing. Okay. So that's monotonic. How do we prove that? There's two ways to prove that. Derivative, yes, derivative, and the number line test. Right? And also, what is the second one? Well, you can do it ratio or compare. Compare a to the n plus 1 versus a to the n. So sometimes you can put in ratio, sometimes you can just compare them side by side. So for example, 1 over n and 1 over n plus 1. Right? You can say something is less than something, and then you can create a statement, and you can longer see measure that truth. Yeah, so and you can divide it by, so if you look at sequence, you can say divided by highest power, or you can do L-Hopper rule. And those are things about that. We also talk about a little bit about squeeze theorem. We also talk about how do you write your sequences, and we did a practice of that. And then we're gonna go to the second part. The second part, we talk about start or introduce about series. What's the difference between series and sequence? Yes, series is adding every single term. So an n equal to 1 to infinity, that's equal to a1 plus a2 plus a3, dot, 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 dot. And we have talked about the series diverge when they go to infinite, of course. And then we can say the partial sum. But the most important series that you can get a result of the series, like you can get a sum or infinite sum. So which only two things that you can get infinite sum? The only thing that you can get a sum is geometric. Yeah, it's also telescopic too. Telescope series, right? We say series. So we can get telescope series, we can geometric series. Geometric series basically 1 over a minus 1 minus r, right? A1. And r has to be what? R greater than 1 is diverge, right? And r is less than 1. R is less than 1 is converge, or absolute value r. So we know this one. Telescope series usually require one thing before you get a telescope. What do you do? What do you think it require you to do? Usually question's gonna involve the what? Partial fraction. Good. So partial fraction. So don't forget how to do partial fractions because you might have to deal with partial fraction. So you have partial fraction, that means I don't, but I cannot talk over him because he's got a loud voice. All right. So partial fraction. So sometimes you have to do partial fraction with telescope series. How do you know that? How do you know when you do partial fraction? When the bottom is factorable, when the denominator is factorable. Is that okay? So Yin, I'm doing just for you, so you better pay attention. Okay. So you say I want to review a little bit. So you can have this. Now, one of the tests that you should always do first is what? What's the first test you should always do? No. No. The first test you should do is what? N-term divergence test. So first, and we're going to come back to this one because today we're going to talk about something that deal with this. The first test, so I'm going to write in red. First test is usually N-term divergent test. And this test only tests for divergent, does not test for convergent. So this is always the first test because today we're going to talk about this again. Why this should be the first test? Because this could be a first step of alternative series. And then we're going to talk about that. So then you can say the first test you should do all the time because you can find out if something diverges. You don't have to do anything anymore. So is that should be the first test? Yes, absolutely, because that's first test you should do because it's diverged already. Okay, so that should be your first test. Now I want to talk about sub things about this. This is this. So when limits n approach to infinity of a to n is not equal to 0, then it's automatically diverge, right? The series diverge. Sorry, series of a to n equal to 1 to infinity diverge. But what if limit n approach infinity a to the n equal to 0? Does that mean converge? No. Do not mean converge. Right? Do not mean converge. However, if the reverse statement is true, so the do not converge on a series. So series of a to the n equal to 1 infinity. Now, if summation a to the n equal to 1 to infinity converge, then limits n approach infinity of a to the n must equal to 0. That is true statement. Is this okay? So does when they equal to 0 does not mean converge. But if the series converge, then the sequence has to go to 0. It has to. Okay. Hopefully that kind of sums up a little bit. The third things that we're gonna learn is the integral test. The integral test. And the CPD, COVID positive dive, is continuous positive and D is decreasing, right? How do we prove D decreasing? Two different ways, right? So if anything is done like this, then you can do an integral. The integral from 1 to infinity. So integral of 1 to infinity of f of x dx is equal to summation of n equal to 1 to infinity of a to the n. No, sorry, n. Either both converge or both diverge. Yeah, integral test is something you have to do integral. And but it has to have fulfilled condition, continuous function, decreasing, and positive. Okay. And usually you have to know, like, on the sub things that you have to know is the e to the x graph to the left side, right? And also the tan of x, like those things are a pi over 2 and negative pi over 2. So that means when limit as x approach infinity of the arc tan is going to be pi over 2. So those are things that you should know also. Is that okay? P series, my favorite series. My favorite series is going to be n equal to 1, infinity of 1 of n to the p. If p is greater than 1, is diverge or converge? P, oh yeah, so p is, so I got confused with something. Converge, right? Is 0 to p less than 1 is what? Diverge, right? Even as much as 0.99999.
Equal to sign.
Yep. So, with that being said, that's gonna be diverge, and then we say, oh yeah, done. This is an easy test. You know, you should not have problem with this test. This is also one of the go-to tests. Is very, very good to go to because you can test that, especially with the direct comparison tests. So DCT.
Wait, let's go back up.
DCT is what? Direct comparison test. So we talk about this test is a little bit different. We talk about so DCT is gonna be summation of n equal to 1 infinity, and it's an less than bn less than 0. So it's kind of like squeeze theorem, right? And summation of b to the n converge. Then summation of n equal to 1 of infinity of a to the n is what? Is what? If a to the n is less than b to the n, and the b to the n's converge, that means what? It's not diverge, you dumb dumb. If you less than the converge, yeah, so this is converge, right? If this converge is b to the n converge, then it doesn't matter equal. If it equal, it's still converge, right? Because less than, it cannot be diverge. So this has to be this is actually converge. If a to the n equal to 1 infinity is diverge, and will be the series of b to the n. Is b to the n is greater? Yeah, so if it's greater than diverge is what? Diverge, right? We also talk of between here. We also talk about harmonic.
Say if b to the n is diverged, isn't that the thing that doesn't justify?
No, a to the n's diverge and b to the n is bigger than diverge, so it has to be diverge.
For the bottom.
Yeah, so b to the n has to be diverge if a to the n is diverge. You're already bigger than diverge. If bigger than diverge, it has to be diverge. If smaller than diverge, is not necessary, right? We also talk about harmonic series. What's a harmonic series? One of the infamous series you have to know. 1 over n. Again, we're going to come back to this. This is diverge. Not only in this diverge, according to Mr. Ye, his own way of thinking might not be mathematically correct. I think this is the best way to tell a borderline diverge. Because 1 over n is definitely diverge, but 1 over n to the 1.01 or 1.00001 is going to be converge because of P series. That's why the P series says, where's the P series? I forgot what's P series. A P series, That's what this is greater than 1, it's converged. So 1.00001 is automatically converged. Okay, we did the direct comparison test. So we did direct comparison test, and we did a couple example like that. Especially is summation of 1 over 2 plus square root n equal to 1 infinity. We did a comparison. What do we compare with? 1 over what?
1 over square root over 1.
Yes, but we find out 1 over square root n is what? It's not a good thing to compare with. Why? It's diverge. Now, is 2 plus square root n less than or greater than that? Less. But if you less than diverge, I have no idea. If something less than diverge, like if you have something less than, you have let's just say I'm the borderline. I'm on the borderline, but if you have less than me, then it's you are poor, right? And if you have greater than me, but it could be converge or diverge, right? So no, you compare with 1 over square root n first. But if you compare 1 over square root n, is inconclusive. Why is inconclusive? Because a summation of n approach infinity of 1 over this is 1 over square root n is diverge, right?
If a bigger number is too big,
Due
that
to
doesn't tell us anything.
P series, right? Now, is 1 over 2 plus square root n, is that less than or greater than? So this is, if this is n equal to 1 infinity, this is less than, right? Because there's 2 plus on the bottom, right? So this one would be less, right? However, if it's less, that means what? I'm less than diverge. I'm less than diverge, it doesn't mean I'm diverge or converge. Is that okay? So what do you compare with next? What? 1 over n. So you compare this series to 1 over n. So you're going to say, hey, summation n equal to 1, infinity 1 over 2 plus square root of n, compared to 1 over n, summation n equal to 1, infinity. Is this greater than or less than? Right? This one is the harmonic. And this is the diverge according to this. So is this greater than or less than? So if I'm greater than diverge, right? If I'm greater than diverge, it has to be diverge.
Yeah, n is greater than bn.
Yeah, but you have to be greater than n has to be greater than 4. Yeah, n has to be greater than 4. Why is n has to be greater than 4? Because only is 4 that's going to be whole truth.
That's when it becomes equal and then it offsets.
Yeah, and we draw both graphs to show you that.
They shouldn't be continuous with the word.
What?
Shouldn't be continuous with the word.
It doesn't matter because continuous is only a sequence. So sequence start at 1. So it doesn't have no asymptote there because asymptote occur at 0. Am I going too fast?
No.
No, okay. Then we use limit comparison test. What's limit comparison test? That means you put a ratio of one series to the other series. You not compare the series side by side. You put it in ratio. So if you put something in ratio, few things will happen. One is if you put a comparison of ratio, 3 things can happen. One is going to come out a number. One is going to come out a 0 or infinite. Well, 0 and infinite just depends on which one you put on top, which one you put on the bottom. Because the bottom is larger, then it's going to go to 0. If top is larger, it's gonna go infinite. Does that make sense? So if they are roughly the same, if they are the same, then series is gonna be same. So that's what I'm saying. If you put a ratio, they say, okay, if it doesn't matter where you put, right? A_n is greater than 0, it has to be that. B_n is greater than 0, and the series is like that. And then you put limits of n approaching infinity of a to the n over b to the n. That's equal to L. That's a finite and positive. Then it's finite and positive, then both. So summation n equal to 1, infinity a to the n is going to be both converge or diverge. Both converge and diverge. Or diverge, sorry, or diverge. So that makes sense. Then you say, okay, well, we did a couple examples. The last example we did not do. We did this first example first. N equal to 1, infinity square root n over n square plus 1. We did this one, right? And what do we compare with? What do we put ratio with that we know is converge or diverge? What do we put? This part, right? We're not including the n plus 1. So it'd be square root n over n squared, right? And that's equal to n to the 1/2 times n to the square. And that's equal to 1 over n to the 3 over 2. Is that converge or diverge? It's a converge because what? Greater than 3 over 2. So we divide it by this. We find out it's actually equal to finite. So we take this. Limits as n approach infinity of square root n over n squared plus 1 all over n 3 over 2 over 1. So that's equal to n squared over n squared plus 1. Limits n approach infinity, that's equal to 1. So if it's equal to 1, they both converge. Okay, so last example before we end the day, it was this one, n equal to 1, infinity n to the 2 to the n, all over 4n cubed plus 1. What do we compare with? N to the 2 to the n and 4n cubed plus 1. What do we compare with? Just don't worry about that one for now. Will be n2 to the n over 4n to the 3. Can I simplify that?
Yeah.
2 to the n over 4 to the
Squared.
N squared. Okay, so that's, don't worry about a 4 because a 4 is constant. So we're going to compare 2 to the n over n squared. Is this a converge or diverge series? That's an interesting one. Is this converge or diverge series?
It was bigger.
How do you know it's diverge?
But it's a little bigger. The top one is.
Yeah, but that's not good enough. You cannot say top one is bigger. But how do I know this is diverge? How do I know it's a diverge series? What? N-term test. Good. So we compare this, right? A_n is equal to 2 to the n over n squared. We can say n test. Limit is n approach infinity of 2 to the n over n squared. So how do I approach infinity? If I approach infinity right now, it's going to be infinity over infinity. So what are you supposed to do? You'll have to rule. So let's just take a derivative. And if you take a derivative, it's going to be ln2 2 to the n, 2 to the x, right? If I do, that's going to be 2x, right? And then you take a derivative again. So when limits as n approach infinity, then that's going to be ln2 times ln2 times 2 to the x over 2. Limit n approach infinity. Guess what? This is going to be infinity, right? So this one's diverge. So we know that this is diverge. Now, can you do this? Can you do this to do limit comparison test? Try it now. The hard part is to figure out this is diverge. The other parts are actually fairly easy. Let me know if I'm talking too fast. I feel like I am.
Did you drink like an energy drink this morning or something?
Maybe. Teaching math give you energy.
You look like this to me. Hold
There's a Ming for me.
on.
Did you guys simplify that one? So you're gonna have limits as n approach infinity of n2 to the n2 to the n, right? Over 4n cubed plus 1. All over what? 2 to the n over n squared.
Yesterday,
I cannot see that far.
like even the eyes.
Really?
Yeah.
The Asian?
Except you're on the iPad. Like you're so.
Look
at
for
his look.
Pepe Silva, Ming. What's Pepe Silva?
I have no idea, but you just remind me a lot of this meme.
Oh, I don't know that show.
You look all over this guy, except he's on the iPad. Oh, we have to do Asian people. So, I mean, I asked Nelly if we can use these and our pictures. What she said today?
So this cancel out, right? Nicely. And this is gonna be ln approaching infinity of n cubed over 4n cubed plus 1. So that's gonna be 1 over 4, right? So it's 1 over 4 is what? Positive infinite. So if this is diverge, this must also diverge, right? And you have to say due to which type of test? Limit comparison test.
Do you have to specify the other test that you took to identify that one diverges?
Yeah, you have to prove this one diverge and the other one diverge. Okay, how much time I have? Oh, good, yay. Okay, so we're gonna talk about last series test. Trust me, this is the last one for this test. No, we're not doing ratio tests.
Root test.
No, we're not doing ratio or root. They're actually easy.
I know you said facial test, but I heard facial test.
We're not doing root test.
Alternating series tests. This one's actually easy. You should not. Anything I say could be a lie. So, what is the alternative series test? So, for example, a good alternative series test will be like something like, hey, summation of n equal to 1 is infinity of -1 to the m plus 1 times 1 over n. So what's defining alternating? What is alternating here? This, right? So this is the first requirement to use AST. It has to have -1 to the n plus 1 or -1 to the n. Long as they're alternating, it's fine. It doesn't matter what start first. Usually you start first positive, but you can start with negative. It's okay? So that is the first condition to use alternative series test.
Oh, negative.
Yeah, you can have first term as negative.
Yeah.
Not this one, but you can have first term as negative. So let's say -1 to the n.
Oh, okay, this one.
Is that okay? Now, do you know that's alternating? This is gonna be the a to the n, right? The sequence, right? If you have this, and if it's, so I'm gonna write down a condition for you. The condition is they say this, that a to the n is greater than 0. The alternating series. Ian, are you writing down? Summation of n equal to 1, infinity, -1 to the n, an, or, oh sorry, n. Summation of n equal to 1, infinity of -1 to the n plus 1, a to the n. What's the difference between those two? One star negative, one star positive, right? Converge. When two more conditions, so are met. Which is the first condition? The first condition, well, the first one is alternating, right? It has to plus minus, plus minus, plus minus. Second one is, hey, this sounds familiar. Limit n approach infinity of a to the n must equal to 0. Do you remember that? That's when the sequence will go to it will go to eventually plateau to 0, and this looks like an n-term divergence test. But instead, this one is not n-term divergence test. You get n-term divergence test is when they're not equal to 0. But this one, the requirement is that if they equal to 0. So imagine you did n-term divergence test and they equal to 0, and this alternating. Then guess what? You already met two conditions. You need a third condition to be true. So the third condition is basically says this: a to the n plus 1 is less equal to a to the n for all n. Second condition is a to the n plus 1 is less equal to a to the n. What does that mean? What's a good way to say this? What is a layman term of this? Decreasing. Thank you. It sounds familiar, right? So if it's decreasing and the limit of a to the n approach 0, guess what? This series converge without question asked. Fairly easy, right? Now we're gonna do it to this one. Second condition is a to the n plus 1 is less than a to the n, which is decreasing. Okay, so we're gonna test this one, see if it's true. First condition, is this alternating? So we're gonna say A, check. Alternating, check, right? The second one says, hey, is limit n approach infinity on a to the n equal to 0? Is it? Because this is the sequence part, right? This is equal to 0. Check. What's the third condition? It's decreasing. So there's two ways to test decreasing. In this case, you can test with what? 1 over n plus 1 is less than 1 over n. Is that true? Check.
That justifies it.
Huh?
That justifies it.
Well, if you really want to take one step, you can do cross multiply. N is less than n plus
If
1.
I write that in a test, you're gonna.
Well, that's easy, right? N is less than n plus 1 if I do cross multiply, right? N is gonna be less than n plus 1. So this is a check. So if three conditions met, series converge. And why is that converge? Because they are alternating. They are limit a to the n is becoming 0, but that doesn't mean it's converge, but they have to be alternating and reach 0 at the same time. And they have to be decreasing. And that's a one series. So this is actually another infamous series. Do you remember the last time you have this? N equal to 1, infinity 1 over a to n. This is called a harmonic. Harmonic series. Convert or diverge, right? But this one is what? It's alternating harmonic. Okay, so it'll be -1 to the what? N plus 1 of 1 over n. So this is called alternating. And this part is gonna be harmonic. So it's alternating, harmonic, series, converge. Alternating, harmonic, series, converge. Alternating, harmonic, series, converge. Okay, so I want you to see if this one converge or not. N equal to 1. Infinity n over -2 to the m minus 1. No.
It's 4 minutes left. Give it a break.
For one time, I agree with Yin. No, I actually feel really energized. Today.
Yeah, like what did I do?
Join SGA. I heard
Yeah.
there's a nap time in SGA. Is it mandatory nap time in SGA? That's what I heard, right? Did you get F for not taking a mandatory nap time?
Oh, why did kindergarten start like that? Don't even do anything. Probably around.
All right, fine. We're gonna finish this off tomorrow, but alternative series. This is a converge.
How's this good?
Which rule?
And plus one.
Let me see if I write down the question right.
Yeah, because there's only one is n and n plus two, or also n minus.
That doesn't matter. Yeah, but usually +1, just because you don't want to have a negative exponent. This is a -2 to the m minus 1. But you still at n equal to 1, so it doesn't matter. So it's gonna be 0.
Isn't your n
Plus 1%.
No. Why haven't it been 0?
I'm gonna finish this tomorrow. So today I'm gonna give you a limit comparison test to make sure you get used to, and some review tests. So that way you have this. Tomorrow we're gonna finish this off, but we're gonna talk about remainder series. So tomorrow it's very complex. Yeah, but there in this test has a little bit more. As you have to find error. Friday.
Well, for me, it's on Thursday. Thank you for the
Huh?
Thank you for the review.
Okay.
Just go over it all and I'll like make up one new thing that I didn't have in my notes. But also now they're all in one page or two pages instead of over like 10.
Yeah. Bye.
Mr. Ye, I have a question. Mr. Grandma. Oh. Jay. Mr. Ye, the third condition does not satisfy, right?
What?
The plus one.
It does satisfy. They converge. They converge.
Is the limit zero? Wait, Connor, did you get the limit equal to zero? Yeah. I got that, but I don't get the last part. You do n plus
We'll talk about it tomorrow. We'll finish it off because they gotta finish the other part anyway. But yeah, homework is already posted. I think.
I'm happy to. You're not even gonna go over root testing. Root comparison.
Why we need to do root? I haven't needed to do root. I'm gonna do alternative series remainder and then conditional converge and absolute converge and then we're gonna do root test next time. Root test, we're not doing root test. Root test is on AP exam. It's not on AP exam. Ratio test is on AP exam. We only have one more test to go. We have another sub one. We have like two more things that we need to adjust, but after that, we are only gonna do
This was gonna stay here.
so we already kind of finished alternate series here, except this example. And we're gonna talk about absolute converge and conditional converge, and but using the same test. And then we're gonna start a test. Oh, we're gonna talk about error also, the error of alternative series, and then we're gonna do a test. After that, we're gonna do a ratio test, radius of convergence, and Taylor series. And then we're done. Taylor series and power series.
All this till Friday?
Huh?
All this till Friday?
He didn't get for the first.
All this stuff is till Friday. Friday. Too.
You be.
Well, I double guessed myself in that process. I'm actually really excited.